let's look at the second sorting and searching problem, appointments. So what's going on here? We have n people and m appointments, and we want to give people appointments, pair them up, right? And everyone has a size, and there's some range, and they will accept appointments sort of within that range, right? Specifically, this, right? If their size is x. And so everyone has their own size, and each appointment has a size, and so we want to pair them up as many as we can. And we're supposed to print the maximum number that we pair. And there's 200,000 for each people, and all the numbers are up to 1 billion. So let's think about this. It helps to draw this out, maybe. So we have our people, and we have some appointments. Right, and we have some range around each person, which is the same for everyone. Forgive my drawing. And so we want to, pick points to match up. So this is a very bad illustration because I've just given everyone sort of a very obvious thing. So let's first see some challenge. Let's say it's like this, right? So these are the people in the middle of the range, and here are the appointments. And so this guy could go to either appointment, but this guy only wants this appointment. So if we just sort of randomly start pairing things up, if we pair these guys up, that's bad, because now these guys can't pair. What we should have done is pair it like this, and now we get 2 instead of 1. So that's maybe a challenge. So what are we supposed to do? So the big idea here is that we should always pair the guy who wants the smallest apartment with the smallest apartment we can give him. And so, why is that? Right. So let's say this is the guy, and there's apartments here and here he could take. He should always take this one. And why is it? Well, we said he was the smallest guy, so everyone else is somewhere to the right of him, and it's always going to be easier for them to take a bigger apartment, right? Because they're to his right. So if this guy takes the smallest apartment he can, that makes it easier for everyone else, right? That's, I guess we would say that it dominates the other choices, right? Taking this one, regardless of how the other guys look, is going to be better than taking this one. Because the other guys are strictly more likely to be able to use this. Because these guys are all bigger, and so the bigger one's going to be closer to them. And the fact that all the intervals are the same length is important here. Right? You might worry that this guy to the right is so far that someone bigger, can't even use it. But if this guy could use it, then any guy bigger than him can also use it. Well, as long as it's not so much bigger. Anyway, so that is going to be the idea, is that we're going to each, go through the guys from smallest to biggest, and each assign each of them so the smallest appointment that they can. So let's do it. Okay, so as always, IO stream stood LL and M, keep them in. It's actually NMK. Yep. And then we have a people. Let's say it's A. And the appointments. Let's say it's B. Size M. I don't know why I named this I. J doesn't conflict with the I above. And we said we wanted to go from smallest to largest, so let's use sort. So sort is a very important function. As the name suggests, it sorts the array from smallest to largest. If you want from largest to smallest, it's a little trickier. I won't talk about it here, but you can do it. Or you can just use the fact that largest to smallest is the backwards. Anyway, it takes the input in kind of a funny way. Just, I guess, know this. These are iterators, which is, I don't know, the API that C++ decided to use. But anyway, this is how you sort a list. I guess the point of this is that you could sort like a section of the list if you really wanted to. Right? You could do this to sort the first 10 numbers. But we'll pretty much always just sort the, a whole thing. We do need to include algorithm to get sort. And we also want to sort the apartments, but you just said you want to get the smallest apartment. Okay, and now we can go through each person. Keep track of what apartment we're looking at and how many people we've paired up. So if while the apartment is too small, so while the apartment is too small, like, skip that apartment and keep going. And by the way, we know that in a too small apartment that's too small for this guy, it's going to be too small for anyone, because this is the smallest guy left. And once we get past the ones that are too small, we might be at the end, so we have to check for that. And check if it actually meets the condition, right, which is between this. I guess they're not totally clear if it's inclusive, but I believe it is. So if that apartment works, then that counts, and also we used up the apartment, so we need to increment BI, right? So like BI is what apartment we're looking at. Yeah, so we skip all the too small ones, we talked about that, and then if you actually find one that works, you need to skip that too. If you don't find one that works, by the way, it might work for the next guy, so you don't want to skip it yet. And that's actually it. Right, we're going through all the people and just assigning them to trying them on the next unused appointment. Wow, too used to Python. It's a cool error message. In Python, you can actually do that triple thing. We were saved by W error, by the way. That's pretty nice. If we had not been compiling with the warning flags, that would have just gone through and meant something, not sensical. The answer